Hello everyone. Today I am going to explain about the Newton-Raphson method. This method is for solving polynomial and transcendental equations. This topic is from Numerical Methods, second unit from Laplace transforms and numerical methods and complex variables subject. So going to the introduction about the Newton-Raphson method. In this method we proceed the way of finding the solution to the given polynomial equation or transcendental equation by using step by step. That is step 1. We find the interval open interval a comma b containing the solution of the equation f of x is equal to 0. So we have to find the interval a comma b, that is find by using the substituting a b values in f of x where it is less than 0, where it is greater than 0, or f of a into f of b is less than 0, then that is the interval of the root x, that is called open interval a comma b. First we have to substitute the values from 0, or sometimes we have to go to the negative values also for x. So step 2, let x is equal to x naught be the initial guess or initial approximation to the equation f of x is equal to 0. So step 3, we use xn plus 1 is equal to xn minus f of xn by f dash of xn as the successive formula to find approximate solution or root of the equation f of x is equal to 0. In the Newton-Raphson method, we use the formula. We have to find the iterations by using the formula. Xn plus 1 is equal to xn minus f of xn by f dash of xn. So by using this formula, we find the number of approximations where the at least 2 or 3 approximations are equal, then we can stop the approximate values. That is going to the fourth step, then x1, x2, x3 so on are calculated, and we will continue this process till we get the root of the equation f of x is equal to 0 up to desired accuracy. Now going to the example, solve x minus 2 sin x minus 3 equal to 0. Correct to two significant figures by Newton-Raphson method. Correct up to 5 significant digits, means that at least 2 significant values are equal, and we have to correct to the 5 significant digits to the answer. So first we have to write the given equation x minus 2 sin x minus 3 equal to 0. This is called f of x. We have to start to find a b values, then substitute x is equal to 0 in f of x, that is called f of 0, that is equal to, we get minus 3 because of x value 0 and the sin x value is also 0, we get the value is minus 3. Next going to f of 1. F of 1 is equal to, means x is equal to, we are substituting 1, we get 1 minus 3 minus 2 minus 2 sin 1, value is minus 2.8415. This value is less than 0. Next going to f of 2, we are substituting x is equal to 2 minus 3 is minus 1 minus 2 sin 2, value is minus 1.9092, it is also less than 0. So going to the f of 3, then that is equal to minus 2 sin 3, that is equal to minus 0.2822, it is also less than 0. So wherever you get the less than and greater than, then only you can stop the values. So that's why in first 3 all are negative values, so that's why it is less than 0. Next going to f of 4, that is equal to 4 minus 3 1 minus 2 sin 4 is equal to 2.5136, it is greater than 0. So that's why our root is between 3 and 4. So the real root of the equation f of x is equal to 0 lies between 3 Then first let we take the initial value x naught is equal to a plus b by 2, that is 3 plus 4 by 2 value is 3.5 be the initial guess to the equation 1. So now going to the xn, means xn plus 1 is equal to, we have a formula xn minus f of xn by f dash of xn, but here we want to find the first approximation x1, so that's why n value is 0, that is x naught minus f of x naught by f dash of x naught. Here x naught value is 3.5, so that's why we can substitute 3.5. 3.5 minus f of 3.5 by f dash of 3.5. We can substitute the 3.5 in the f of x, and f dash of x from the given equation is x derivative is 1 minus 2 into sin x derivative is cos x. So that's why 1 minus 2 cos x is the derivative of f of x. We can substitute in that equation. Then we can get the value from calculator, that is 3.0817. Next, going to the next approximation, x2 equal to, means n value is 1, that is x1 minus f of x1 by f dash of x1. So f of x1 is 3.0817, substitute it and find f of 3.0817 by f dash of 3.0817. So we get the value is 3.0944. This is the x2 value. But the value is vary from 0.38 and 3.09. So that's why we can go to the next approximation. x3 is equal to x2 minus f of x2 by f dash of x2, that is equal to, we get the value 3.10450. So going to the x4 is equal to x3 minus f of x3 by f dash of x3. You can substitute the value of x3 and find f of x3, f dash of x3, and we get the final answer is 3.10451. So three values are, means 3.10450 and 3.10451 approximately equal. So that's why we can stop here. The root of the equation is 3.10451 for 5 significant digits. So this is the method to find the Newton-Raphson to the given equation and find the root of the equation. Next equation is polynomial equation. Solve x power 4 minus x minus 7 is equal to 0. Correct to two significant figures by Newton method or Newton-Raphson method. Correct up to 6 significant digits. So here we have to find the value of x by using the Newton-Raphson method, and f of x is equal to here x power 4 minus x minus 7. So now we have to start the root, finding the root by using substitution of x is equal to 0. F of 0 value is minus 7, means x value 0. So first two values becomes to 0, the value is minus 7, it is less than 0. And f of 1 is equal to 1 minus 1 cancel, again we get minus 7, that is also less than 0. Going to the f of 2, that value is 5. You can substitute 2 in this equation. We get the value is 5. It is greater than 0. So that's why our root is between 1 and 2. And also f of 1 into f of 2 is less than 0. By using the intermediate value theorem, then the root is between 1 and 2. We can write f of x is equal to 0. Going to the approximations, the root is between 1 and 2. So 1 plus 2 by 2 value is 1.5. The initial guess is 1.5. Then going to the Newton-Raphson method, formula xn plus 1 is equal to xn minus f of xn by f dash of xn. By using that n is equal to 0, x1 is equal to x naught minus f of x naught by f dash of x naught. and here x naught value is 1.5. Substitute it 1.5 minus f of 1.5 by f dash of 1.5. We can calculate the value, means f of 1.5 means we can substitute the 1.5 in f of x, that is x power 4 minus x minus 7. So we can substitute it, and f dash of x, what is the f dash of x? 4x cube minus 1. X power 4 derivative is 4x cube minus x derivative is 1. We can substitute the value 1.5 in 4x cube minus 1 and we get some value. Then we can calculate the value from this equation. We get 1.78541. Next, going to the second approximation, x2 is equal to, how to find this? We are substituting n is equal to 1. x1 minus f of x1 by f dash of x1, that is 1.7854 minus f of 1.7854 by f dash of 1.7854. Here f of x, we are substituting x value in f of x and we are substituting x value in f dash of x. We get the numerical value, then we can simplify it. We get 1.85876. Next, x3 is equal to x2 minus f of x2 by f dash of x2. So x2 value is 1.8587 and we can substitute in f of x and f dash of x and simplify it. We get 1.85643. So that's why here we are varying the value in the last 3 digits. So that's why we can go to the next approximation. x4 is equal to x3 minus f of x3 by f dash of x3. So then we can get the value is 1.85632. So in the given problem also they are asking only 2 digits are approximate and we have to conclude with 5 decimals. So that's why we can stop at x4 because of 2 digits are same for x2, x3 and x4, that is 1.85, 1.85 and this is also 1.85. That's why we can stop here. Here sixth digit, third digit also 6 is also same, so that's why we can stop here. So the root of the given equation is 1.85632 by using the Newton-Raphson method. Now I will explain the topic Lagrange's interpolation formula from interpolation topic. In that topic we have Newton's forward, Newton's backward and Lagrange's interpolation formula. So now we will discuss about Lagrange's interpolation formula. So Lagrange's interpolation formula introduction is, the Newton's forward and backward interpolation formula can be used only when the values of x are at equidistant. If the values of x are at equidistant or not at equidistant, we use Lagrange's interpolation formula. So we have a drawback in Newton's forward and backward, that two are used for equally distant equidistant values of x, but it is also used for not equidistant values of x. So this is the advantage of Lagrange's interpolation formula. So let y is equal to f of x be a function such that f of x takes the values y0, y1, y2, so on yn corresponding to x is equal to x0, x1, x2, so on xn. That is y I equal to f of xi, where I is equal to 0, 1, 2, so on. And now there are n plus 1 paid values xi comma yi, where I is equal to 0, 1, 2, so on, and hence f of x can be represented by the polynomial function of degree n in x. So this is about the Lagrange's interpolation introduction, and going to the formula for Lagrange's interpolation, that is y is equal to, or f of x is equal to x minus x1 into x minus x2, so on, x minus xn by x0 minus x1 into x0 minus x2, so on, x0 minus xn into y0. So plus y0 means y of x0 plus x minus x0 into x minus x2 so on x minus xn by x1 minus x0 into x1 minus x2 so on x1 minus xn into y1. Y1 means y of x1 plus so on. Nth term in the Lagrange's interpolation is x minus x0 into x minus x1 so on x minus xn minus 1 by xn. Last term is xn minus x0 into xn minus x1 so on xn minus 1 into yn. Yn means y of xn. So this is about the Lagrange's interpolation formula. So we have to remember only one important point. Initial values of x means initial value of x is x0. So in the numerator there is no x0 terms. In the denominator we are subtracting from x0. Here in the second term, so second term in the x series is x1. So here missing the x1 means subtracting x1 from x is missing and the denominator subtracting from x1. You have to remember like that, easy to write the formula. So this is about the Lagrange's interpolation formula. Going to the example is using Lagrange's interpolation formula, find y of 10 from the following table. They give the x values 5, 6, 9, 11. They are not equally difference. So y values are means difference of x terms is not equal because of it is 5, it is 6, 9 and 11. So y values are 12, 13, 14, 16. So now we can use the Lagrange's interpolation formula and solve the value of y of 10. So here first initial value for x is x0 equal to 5, x1 is equal to 6, x2 equal to 9 and x3 is equal to 11. Y0 equal to 12 means y of x0. Y1 is equal to 13, y2 is equal to 14, y3 equal to 16. Simply we can write the formula for Lagrange's and substitute the values. Here we have to take up to y3. Y3 means 4 terms we have to consider in the formula. So that is y is equal to f of x is equal to x minus x1, x minus x2, x minus x3 by x0 minus x1 into x0 minus x2 into x0 minus x3 into y0, and second term x minus x0, x minus x2, x minus x3 by x1 minus x0 into x1 minus x2 into x1 minus x3 into y1. Y1 means y of x1. So next term plus x minus x0 into x minus x1 into x minus x3 by x2 minus x0 into x2 minus x1 into x2 minus x3 into y2 y of x2 plus x minus x0 into x minus x1 into x minus x2 by x3 minus x0 into x3 minus x1 into x3 minus x2 into y3 y of x3. We can substitute all the values for x1, x2, x3 and x0 and y0, y1, y2, y3, y values in the all the terms of equation. We get the equation is x minus 6 into x minus 9 into x minus 11 by x0 value is 5, 5 minus 6, 5, and here also it is a 5, x2 value is also 6, so that's why 5 minus 6, 5 minus 11, and substitute all the values in the second term, and y1 value 12, y0 value 12, y1 value 13, y2 value 14 and y3 value 16. You have to substitute all the values in the given formula, and after that finally you have to substitute x value is 10 because of we want to find y of 10. So substitute all the values in the Lagrange's interpolation formula and take x is equal to 10. We can get y of 10, that is y f of 10 is equal to, simplify the values with x is equal to 10. We can get the value is 1 by 6 into 12 minus 13 by 3 plus 5 into 14 by 3 into 2 plus 4 into 16 by 12. After simplification we get the value is 14.6663. So this is the final value to the given function and by using the Lagrange's interpolation formula. Once again, I am repeating that the Lagrange's interpolation formula is mainly used for x is not placed with equally distanced. So that's why here we can observe the difference is here 1, here 3, here 2. So that's why if the difference of x terms is vary, then we can use the Lagrange's interpolation formula. Otherwise, we can use the Newton's forward or Newton's backward interpolation formula. So this is one of the topic from interpolation. That's all for today.